Okay, what is address mapping? What do you know about the addresses which we use? So here we will be using a IP address and a MAC address, right? Yes or no? So when we are using a network layer, we will be delivering the packets or the data which we get from the upper layer, right? So when we are delivering the packets to a host or a router, we require two levels of addressing here. So one is logical addressing and other is physical addressing. So here the logical addressing is nothing but the IP address, and the physical address is nothing but the MAC address or the hardware address which the host is having, right? So here we need to map that logical address to its corresponding MAC address. So whenever a host is transferring data or packets from one host to other host, it should know whether the IP address of the destination host or it should know the MAC address of the destination host. Then only it can be able to transfer the data from source to destination. So this address mapping we can do either in a static way or in a dynamic way, right? So if you see here, we will be using protocols to help us to traverse the data or the packets from source to destination, right? So if you consider here ARP, what is ARP? So it is a protocol which is having address resolution protocol. So we have IP packets which is having a IP address and a MAC address, right? So whenever we are going to transfer the data from one node to other node, we need a protocol called ARP. So this ARP is nothing but address resolution protocol, right? So sometimes we need to reverse the mapping so that we will get to know what is the physical address and the logical address for that particular host which we are sending the packets, right? So here we are going to use three or five protocols. One is ARP, RARP, BOOTP, and DHCP, right? So in address mapping, what we need to know is what is the IP address and what is the logical address and what is a physical address we need to know, right? So we have hosts and we have routers and we have all the hosts that we can traverse, right? So in this diagram, if you see, we are using two systems and we have different types of systems which is attached to this particular network, right? So when a system A wants to communicate to system B, or it has to travel or send the data or the packets from system A to system B, first what system A will do is it will request the system B, and what it should know, it should know the IP address or the physical address, right? So here in ARP, what we are going to do, we are going to request ARP by using ARP protocol, looking for the physical address of system B, right? So here what in this particular network we are using a broadcast. Broadcast is like one to many, right? So one system A is giving request to system B so that all these nodes which is connected to this network will also get this particular request. So this is known as broadcasting, right? So how we will be getting a reply in ARP is, so the system B will directly give the reply to the system A by using this unicast. By mapping the physical address of system A, it will send the reply from system B. So here it will take the IP address and it will search for the IP address in all the nodes which is connected in this network. But in reply, what it will do is it will search for the physical address, that is the MAC address, and it will map to that system and it will reply to that particular system. It won't reply to all the nodes which is connected to the network. So this process is known as unicast, right? So this is how this ARP protocol will work. So next we have a cache memory while we are using ARP. So if you see here, we have system A and system B, right? Which is connected in a network, right? So when we are requesting it, we are using a broadcast for each IP packet, right? If we wanted to send, we are using a broadcast network here. So here what we are going to do is, whenever this reply is coming back to system A, what we will do, we will be having a cache memory where we can store, and we will be keep there that particular reply for 20 to 30 minutes until the space will get filled, and it should be, that memory will be exhausted, right? Till then it will wait in that particular memory, and then before sending this request again next time, first it will check into the cache if there is any reply that is found that should be mapped. So for that we will be using this cache memory in ARP protocol. So the next one is ARP packet. So if you see here, you have a packet here, right? So we have different fields in ARP packet, right? Yes or no? So the first one is hardware type, right? And the next one is protocol type. So here the hardware type is having 16-bit field, right? If you take consider the 8 bits and 8 bits, it is 16 bits, right? So 16-bit field will define which type of network it is, and where ARP, that is this protocol, is running. And we have LANs and WANs when we are using this kind of protocols to transfer or transmit the packets or the data from source to destination, right? So here we will be using LAN, and it will be having an integer based numbers. And for example, we will be mostly taking Ethernet here to use in this hardware network, right? So the next field is protocol type. If you see here, it consists of 16-bit field, right? So if the value here we are taking IPv4 or IPv6 internet protocol, we will be taking, we have different versions, right? Version 4 and version 6 protocols. So here the value may be 080016. So here the ARP protocol will be used with any high level protocols in this protocol type. So what is the next field? Next field is hardware length, right? So in hardware length, we have only 8-bit field. So what does it mean is, it is showing the length of the physical address in bytes. So what is the length of the physical address it is showing? For example, if we take Ethernet, so the length of this is 6, and the next field is protocol length, right? So if you see here, the protocol length is also having 8-bit field, right? So here what it will represent, it will represent the length of the logical address. Hardware length is showing the physical address, and here the protocol length is showing the logical address in bytes. So if we take the IPv4 protocol, the value is 4 here, right? So the next field is operation. So here we are getting a request message 1 and reply 2, right? So the operations we can do, like two packet types are there here. So first one is we are going to request, that is ARP request, right? And the second thing is we are going to do ARP reply. So after requesting only we will be getting the reply, right? So these are the two operations we use in this, right? So the next field is sender hardware address. So here we have a variable length field. So here what the sender is doing, it is sending the physical address to the source, to the destination, right? Sender is nothing but source here, right? So the next field is sender protocol address. So sender protocol address is like it is having variable length field that we did not mention what is the variable length to that particular field. For example, if we take the IP address here as protocol, so when the sender is sending, it will take only 4 bytes because of the IP protocol, right? So the next field is target hardware address. So what is mean by target? It is nothing but the destination hardware address, right? Yes or no? Here the hardware address is nothing but is also known as physical address here, right? So here it will be defining the physical address of the destination or the target. For example, we will be taking Ethernet here in this field. So an ARP request message will be sent. So this field will have all zeros because the sender does not know the physical address while it is sending. It knows only the IP address, right? So the target protocol address, what it will do? It will have the logical address of that particular target, right? The next field. So what it will have, the IPv4 protocol version it will be having, and it will be knowing the IP address of that particular target. Yes or no? So this is about this packet. Yes or no? ARP packet. So you will be having all the information in this slide. And the next one is encapsulation of ARP packet, right? So if you see in this diagram, you will be knowing what are the fields we have here. So an ARP packet is having encapsulated directly into data link frame. So where we can encapsulate into Ethernet frame. So if you take here, we have ARP request or reply packet in the data field, right? So we will see how the steps are there in this process, right? In operating this encapsulation. So what the sender will do? Sender will send the IP address to the target. Then it will wait until it gets the request back, right? So here the internet protocol will ask ARP address resolution protocol to create an ARP request message so that it will fill the sending, that is sender physical address to sender IP address and the target IP address. So here what it will know? It will know only the IP address of that particular sender, right? And the target, that is destination. So destination physical address field is filled with 0 because it doesn't know what is the destination physical address, that is MAC address here. So whenever it is sending a message through data link layer, so it will be encapsulating that frame using the physical address, right, as a source address. So the physical address will broadcast to the destination address, right? So here every host or router will receive a particular frame where it contains the broadcast destination address. So the broadcast will have some particular destination address, right? So here what it will do, I have already told, right? So whenever we are sending through a network, all the stations that is present in that particular network, when ARP is requesting, every node will go at, will have that particular request will reach, right? So here the target mission, it has to give a reply, ARP reply message that should contain the physical address, and the message will be in the form of unicast, right? So it will be directly going back to the sender, right? So sender receives this reply message. So it will know the physical address of the target mission, right? So here we will be using the IP protocol, and we will be using the ARP protocol to send the data from one frame to other frame, and we are using the broadcast network and the unicast addressing from source to destination, right? So this is how we will be using this encapsulation technique here. So if we see here, a packet is having preamble, SFD and destination address and source address, and it is having which type here. Type is nothing but here the protocol versions which we are using, IPv4 or IPv6. So here the data we will be using the ARP protocol for requesting and replying, right? So CRC is nothing but error detection, right? Yes or no? So here we are having four cases how we are going to use ARP, right? So first case, if we see here, we have a sender and a receiver host and we have a LAN here, right? So here the target IP address, that is the destination address, is in the IP datagram here, right? So in first case, what a host is doing, host A has a packet to send to another host on the same network. So it is using same network to send a data, right? So in case 2, what a sender is doing, sender is, we have a sender and a router, right? Yes or no? Here host wants to send a packet to another host in another network, right? So first what it has to do, it has to reach the router, then the router will send that particular data to other host, that is destination host, which is present in the another network or different network, right? So that is going to happen through IP address here, right? Yes or no? And what is case 3 here? So the case 3 is nothing but we have a router that will receive a packet and that needs to send to other network using another router here, right? So what it has to do, it must first deliver to the appropriate router, then that particular router will send to that particular host present in the other network, right? So here we are going to use a routing table. So here the sender and the receiver both are routers, where this receiver router will take that particular data and transfer that data to the destination host where it is present in the different network, right? So that is case 3 here. And the next case is router will receive a packet and it will be sent to a host on the same network. So here the common thing they are using is IP address, right? What source or sender knows is IP address. Based on the IP address, it is sharing the data within that network, same network or with different networks which is present in another network, right? So these are the four cases that we can see in this diagrams, yes or no? So here we have ARP request, that is broadcast, and ARP reply is nothing but unicast in ARP protocol, right? So here if you see an example how we request and reply. So here we have a source and a destination. Source is nothing but A and destination is nothing but B here, right? So if you take this 130.23.43.20, it is an IP address. You clearly understands, right? So the next one is the MAC address, right? The MAC address is nothing but the physical address. So when you take a source, a sender, so what sender will do? Sender will have this table which consists of all the versions, which version it is using, and what kind of data it is going to send, what is the IP address, and what is the physical address of that particular sender it has, right? So this is the sender's address, everything, right? So what it knows, it knows only the IP address of the destination, right? So if you check here, the destination address is same here, right? Dot 25, yes or no? So what this request will know, only the IP address of the destination address it knows. So when it requests to host B, so B, what it has to do, it has to accept the request and it has to send the data by using the physical address here, right? That is MAC address here, right? So by using that, it will give the reply. So this is how request and reply messages will go in ARP protocol, right? So the next one is proxy ARP. So proxy is nothing but, I know you all know what is proxy, right? So what is the general meaning of proxy? So if someone is absent in the class, instead of them, you will be giving the attendance, right? So that is nothing but proxy. It is a general meaning, right? So here we will be using a proxy ARP to create a subnetting effect in this ARP protocol. So on behalf of a set of different hosts, we will be using a proxy ARP here. So whenever a router wants to run a proxy ARP, what it will do, it will be giving ARP request looking for the IP address of one of the hosts present in this diagram, right? So after router receives the actual IP packets, what it will do, it has to send the packets to the appropriate host or router, right? So here if you see in this diagram, we have a router and a host where it will be sending a request. So when ARP request is sending, it is like broadcast network, right? We are going to send this data to all the nodes. So here the administrator is present in this organization, right? So here what they have to do, they have to create a subnet without changing the whole system, so that it can recognize easily the address, subnetted address. So here what they have done is they have added a router that is known as a proxy ARP router. So this router will act as a host that is installed in the subnet, right? So you have different IP addresses here. If you see here 141.23.56.21, 22 and 23, all these are different IP addresses, right? So what it will do, it will send an ARP reply and announces its hardware address, nothing but physical address, as target hardware address. So the router will receive the IP packets, then it will send the packets to the appropriate host. So here what it will do is the router will get that particular request, and that request it will check with other subnets which are present in this diagram. So if it is matching with any of that, it will get the data from that and it will send to the appropriate host, right? And then it will get reply and the reply will given back to the router or the host, right? So this is nothing but proxy ARP here, right? So the next one is mapping our physical address to logical address. So I hope you are not getting confused about the physical address and logical address. So you note it down that logical address is nothing but the IP address here. So if it is a physical address is also known as MAC address and it is also known as hardware address. So here we are going to use other protocols, that is RARP, BOOTP and DHCP. So here the host will know only its physical address, right? So it needs to know logical address also. So we have two different cases. To overcome these cases, we will be using all these protocols. So we have diskless stations. So booting is nothing but we will be booting if there is any problem or situation which cannot be handled that occurred in the system, right? So if a station wants to find its physical address by checking interface, what it should know the IP address, right? But it does not know its IP address, right? So if an organization does not have enough of IP addresses to assign to each station, for example, if you take there are 10,000 employees who are working in an organization, so they doesn't have that 10,000 IP addresses to assign to each employee who are working in a system. So what they have to do, they have to demand few IP addresses from other space, right? Yes or no? From other organizations or from other stations, right? So that it has IP addresses, right? So that what they'll do, the station must send its a MAC address. So you all know, you all will be using the hardware addresses, that is MAC address, right, to connect to an internet. So for that it will take some time lease, right? So because of that we will be using this reverse ARP protocol. ARP is nothing but address resolution protocol. So in reverse ARP, what we are going to do, we are going to find the logical address, that is IP address for a mission that has always its physical address. So here in this case, what we are going to do in reverse ARP is, we know only the physical address, but we need to find the IP address here. So here we will be having a host and routers which are assigned one or more logical IP addresses. So that may be unique and it is very independent of that physical address. So physical address, when I say physical address, it is nothing but the MAC address or the hardware address. So here the IP address of that particular mission is read from its configuration, which is already stored in the file, right? So here we are using diskless machines. So here we will be usually using the booting technique from which will help us to give the information within a minimum time, right? So here what we are going to do, the physical address is having the NIC card, right? So what is NIC card? Network interface card will be having, which is having a unique ID, right? So which will be present in the hardware side, right? So when we use the physical address to get the IP address by using this protocol, we will be using here same the RARP request is used and it is created, and we will be using the broadcast network here. So in another mission, what we will be getting all the IP addresses which will respond as a ARP RARP reply, right? So if you take here, we will be having a serious problem related to broadcasting, right? When we take data link layer, we have a physical broadcast address where Ethernet will be used. Here we will be considering all as ones. So we cannot pass to some particular extent of boundaries in a network, right? So here the administrator will be having different kinds of subnets that need to assign a particular server. We will be using a server here, that is RARP server for each network and subnetworks. So for this, if you take this as an example, how a client and server will communicate in same and different networks. So first example, if you take, so it is boot P. Boot P is nothing but booting protocol, right? Yes or no? So if you take in this booting protocol, you will be having bootstrap protocol. You will be having all the hosts attached to a server. This is nothing but a sub network, right? So we have boot P server, bootstrap servers. Similarly, we have RARP server also. So when we are using this request message, we will be sending the request message from client, right? So here if you see here, 68 and 67 are denoted here, right? So here the 67 and 68 are the host values here present for this computers, and zeros and ones we have taken for ethernets here. So when we are requesting here by using these clients, we will be getting the reply from boot servers. So this is like unicast way, right? Yes or no? So here we will be using broadcast while we are sending request, but while we are getting the request, it will be sending direct the data to that particular host which is mapped, right? The address. And the next one is client and server on different networks. So here we will be using routers, and we will be using the internet through which we can share the packets or the data from source to destination. That is from client to server. So if you take here, we have two different hosts present in a network where it is using the broadcast request, and through router, the router will use only unicast request, and it will go that request to that particular server where it has to reach, right? So this server will act as a communication, and it will give the reply message in a unicast way, and that reply will be sent to that particular destination host. So this is boot p, how a client and server acts in a same network and different networks. So if you see, we are not using any dynamic configuration protocols in bootstrap protocol, right? So here we are going next to DHCP protocol, where we can provide both static and dynamic address allocations. So we can give the addresses manually or automatically, right, by using DHCP protocol. So here the dynamic address allocation protocol is like we have a very pool of temporary addresses for a limited time, right? So the next one is ICMP protocol. So if you consider the ICMP protocol in IP protocol, what we can do is we can provide unreliable and connectionless datagram delivery, right? So connectionless datagram delivery we will be seeing later. So where it does not have any error or error correcting mechanisms. So in IP protocol, we lack a mechanism that where host and management queries will be mostly cannot be answered in IP protocol. Because of these two reasons, we will be using ICMP protocol. So ICMP protocol is designed in such a way that where these two problems can be solved, right? So internet control message protocol. So here we will be controlling the errors, and we will be controlling the error reports and error correcting techniques. And it is also a connectionless datagram delivery where we can send the packets without any connections, right? So the next one is IGMP protocol. So here in IP protocol, we have two types of communication, right? One is unicasting and other is multicasting. So IGMP is nothing but Internet Group Management Protocol. So here what we are going to do, we are going to make a group in a management if it is necessary, and that won't be sufficient for this particular protocol. So here we will be using multicasting communication in IGMP protocol. So here it is not multicasting routing protocol, but it manages group of members which are present in an organization, right? So if you take RARP boot p bootstrap protocol, we have seen, right, where we can share the physical address and the logical addresses in same network and different networks, right? And DHCP is also like we have designed to address allocate the address in a static way or in a dynamic way, right? Yes or no? So in ICMP, what we are going to do, we have different types of messages in ICMP, right? ICMP is nothing but Internet Control Message Protocol. So we can divide this ICMP into two broad categories. In that, one is error reporting messages and other is query messages. So error reporting messages is nothing but it will report problems whenever a router or a host will encounter problems related to the IP packets. And the next one is IP query messages, right? So whenever we are having a pair of data which is being sent to a host or a network manager, we will be having a specific information related to router or another host. For example, we consider a node which can discover their neighbors. They can know who their neighbors are, right? So what it will do here, the host will know and learn about the routers in that particular network which is present, right? So that it redirects the messages, right? So here we have a message format in ICMP, right? We have four fields here. One is type and other is code and the last one is checksum. And we have the rest of the header and data section here. So in message format, what we are going to do in ICMP messages, which type of data we are going to send, and the code field is having which particular message we are going to send, and the checksum is nothing but we all know that is for error detection we will be using, right? And the next one is error reporting in ICMP, right? So how we do in ICMP error reporting? We should know the destination or the source. We need to know how much time it is taking, and we need to know what are the problems that we are facing while we are sharing the data from sender to receiver. Then only we can redirect that particular message, right? Then only we can share this error reporting problem in ICMP, right? So here ICMP will not correct the errors, but what error correction will do is it will use another high level protocol so that it can detect, I mean, it can reduce the errors in the data packets when they are exchanging from sender to receiver. So here the error messages are always sent to an organization where the source will have the information available related to the data which is it is being sent, right? So the data is also known as packets, or we can say the data as datagram, right? So when we are using a route from source to destination using IP addresses, we will be using ICMP source IP address to send the error message to the organization which is present in ICMP. So if we see the IGMP protocol, I have already told it will be having different group of people, right? Management, where they will be able to manage the errors, everything, right? Yes or no? So this is about the protocols which we are going to use in address mapping, right? So IGMP, here what we are going to do, we have different versions of IGMP. So in IGMP we will be having a general query and special query and membership report and leave report. So all this will be are the different types of messages where we can use in IGMP protocol, right? And a message format is having a type, a maximum response time, and a checksum, and a group of people where they will be giving special queries or they may be leaving the reports or general queries, right? So here in IGMP, the maximum response time it will take is, the bit is having 8-bit field in a frame format, and the time it will take is until it get answered the question or the query which a sender is being sent to the receiver or some other organization when it will reach the answer, it will take that particular amount of time as maximum response time here. So here the checksum is nothing but we are going to calculate and carry the error detection, right? And what is group address here? We will be having different IDs in a special query where the members present in a membership, they can report and they can leave the report messages. So how we can operate IGMP is we will be using a multicast router which will be connected to a network that have a list of multicast addresses. So it will be having a group of host which is attached in a network. At least one loyal member will be present in that particular network. So all the members present in a group will be having a unique IDs, right? And they will be having a multicast router in that particular group where they are present. So here we will be using multicast packets for some amount of groups where it is connected to a router, right? So we will be using one or more interfaces to receive this multicast packets which we are going to transfer. So in both cases, what we are going to do is we are going to keep a router and a list of group IDs. Based on the group IDs, we will be distributing the routers and we will be getting the data request and reply by using that particular router in the network, right? So here we have ICMP membership report as twice, right? One is leave report and other is a general report, right? Yes or no? So whenever there are anyone leaving a group, they are going to get monitored and they need to write a report why they are leaving, and they have to know all the IDs and the multicast addresses which is being sent to that particular interface by using routers, right? All this will be done in IGMP organization. So, so these are the protocols where we use for address mapping. So respond to your attendance. So thank you. Respond to your attendance.